Welcome back to part 2, where we're going to give a demonstration and complete an exercise. In particular, we're going to complete an application that connects to Google Maps Distance API service to compute distances between two geographic locations. To demonstrate how this service works, let's take a look at the following URL as an example. Here I've cut and pasted the URL into a Chrome web browser. The origin is Lincoln, Nebraska, and the destination is Omaha, Nebraska. It responds with pure JSON data that tells us that the distance is 95.4 kilometers. Unfortunately, Google has not decided to establish a CORS policy with their map API. Instead, I've had to establish a proxy located on the course web page. Let's take a look at how it works. From the same origin to the same destination, it responds with simply just the distance. This is a proxy. The way that this works is that we make a request to the proxy located at the following URL with these as inputs. There's a script located on the CSCE server that intercepts this request and then makes its own request to the Google Maps API, processes the result, and responds to our request with just this piece of data. Now let's go ahead and integrate this into a small application. Here I have a very simple web page, distance.html. It contains text input boxes for a city, state, and zip as the origin, and a city, state, and zip for a destination. It also has this compute button. Let's take a look at the actual source here. The compute button has an on-click event registered with it. When you click that button, the compute distance function is called, which is located in the following JavaScript source file. To show that this is actually working, let's go ahead and print out to the console. Refresh our browser, and when we click compute, it prints it to the console. Now let's actually implement this function. The basic idea is that we're going to need to make a connection via Ajax to our proxy service. We will want to make sure that we process the results, if successful, and also be able to handle any errors. To do so, we're going to use jQuery's Ajax function. Recall that the Ajax function takes one argument, an object, that contains all the configuration necessary to make a connection and process the results. The first property is a URL that we want to connect to. At this point, let's go ahead and take a look and see what happens when we attempt to connect to the Google service. Cutting and pasting the URL, saving, and going over to the browser, let's reload it. Now when we click compute, computing will be printed out to the console, but take note of the following error. We cannot load data from maps.googleapis.com because it does not have the same origin from where we're serving this HTML page and its script. In fact, the origin here is the local file system. It's not allowed by the access control allow origin. We are violating the same origin policy. Now let's try to connect to our proxy. Now it allows this. Note that we're still violating the same origin policy. The web page and the script are being served from the local file system, but we're attempting to make a connection to a remote server, csce.unl.edu. However, the way that I've set up the proxy is that I've established a CORS policy, a cross-origin resource sharing policy, that establishes that any request to this service is allowed from any origin. Google chose not to support such a CORS policy on their Maps API, and since I have no control over their services, I have to use a proxy. Now let's finish up with the rest of the configuration. The next piece of the configuration is the data that we'll end up sending. The data is simply just a JSON object containing key value pairs. If you take a look at the example that we did previously, you'll see that the key value pairs were separated in the URL with an equal sign. we will need to provide inputs for the origin city, origin state, and origin zip. The service expects these to be named as follows: origin city, origin state, and origin zip. Destination likewise. Where do we actually get these values? Let's use jQuery to pull the values from the form data. We've previously seen how to do this. For example, we can establish a variable, oCity, and make a selector call to the ID of each element. Now we can use these variables down below. The next piece of configuration for Ajax is to establish two callbacks, one for success and one for failure in case the call goes wrong somehow. The success function takes a piece of data. That's the response that will be coming back from the server if it's successful. We can then process it. For now, let's go ahead and just print it out to the console. Let's test it out. From Lincoln, Nebraska to Chicago, Illinois, we successfully received a distance of 842.552 kilometers. Printing it out to the console isn't much use to an end user who would want to see the result displayed on the actual page. We can rectify that by changing what we do upon success. Instead of printing it out to the console, we can modify the HTML document to print the result. We've set up a div element here, which is initially empty, where we can place our results. Its ID is result. We can manipulate its content similarly using jQuery. The data that's passed in here has the following format. There's one property for that piece of JSON data, the distance, which we simply place inside a paragraph element and modify the HTML contents of the result element in the page. And now it works. That's a rather bland way of displaying a result. Let's add some flair using jQuery effects. First, we'll hide it, change the HTML, and then we'll fade it in slowly. We'll also add km at the end to indicate the units. And now when we compute, it slowly fades in. We could add any other effects to indicate that the result was successful. These results are pretty fast, but what would happen if we had a slower network connection or we were processing more and more data? The user wouldn't have any indication that there's some computation going on in the background. So one way to rectify this is by giving a visual cue to the user. We'll do that by adding a loading graphic to the area right here. Where would we want to do that? When a user clicks that button, this function is invoked, which then gets the content of the form and invokes an asynchronous Ajax call. We have no idea when this will begin or end. So if we want to make any changes prior to that call, we should do it here. I have an image file stored in the local file system called loading.gif. Now when a user clicks on this button, the content will be changed to include this image. We saw it only briefly because it was quite fast, but if it were slower, we would definitely see that loading graphic continue for a while. We've considered errors when, for example, if we have no network connection. This would pop up with an error down in the console. We can do something similar to provide a better user experience by echoing an error message on the actual page if something happens. However, we haven't considered errors of a different type. What if I put in a non-existent location? Foo, bar, baz. When this is submitted to the server, it won't be able to compute a distance because there is no such place. And we have undefined instead. This is not very good for the user experience because they don't know what happened. In our success function, before we go and display the results, we should check to make sure that the actual data came through. And provide alternative behavior if it didn't. When building a dynamic application using Ajax, a lot must come into consideration, including security issues, user experience and user interface issues, as well as asynchronicity.